Hi, this is Abidunamasuddegi.
So you see that we are continuing. Okay. So you can see that what is an algorithm.
Yeah.
Any question regarding this?
No. Can you just
Okay.
explain how we can use it and the negative impacts of it and positive and the how it can be biased sometimes and the effects of it. That's all I'm like lost of.
Yeah, it is. You have to just if you study this thing and you will be having more grasp to this algorithm, the topic algorithm. Basically, this is not only one part. You can see that this is so long. It has 9 parts, or I don't think so that this will be finished today. So you can see second part. What is an algorithm? We are already know that it's a finite sequence of well-defined instructions typically used to solve a class of specific problems or to perform a computation. Algorithms are essential in making computers perform tasks efficiently and effectively. Yes. For example, another name of mathematics, can it be?
Okay. Yeah.
Right? For example, if I want to say something in words, I have to write algorithm. If I want to say something with some instructions or with some you can say mathematical expressions, like for example, if I am using some operators, something like that, for example, arithmetic operator, relational operator, logical operators, if I want to use them, assignment operators and equality operators, if I want to use all of these things while expressing my words into some technical language, becomes a pseudocode, or this is also known as the algorithm. There is no difference in pseudocode and algorithms. Algorithms basically written like that. You have to include some English like sentence to explain what is going on.
Yeah.
Then
The
yeah, please.
Actually, no, nothing.
Okay.
Because we took this. Is it okay if you skip to the positive and negative?
Yeah. Basically, some positive aspects and some negative aspects means, for example, you have to check every single aspect while writing algorithms. What would be the negative? That means you have to provide the alternative. Positive means if this happens and how the user will interact with this, so how to communicate. Then another alternative to positive side. For example, like
Yeah.
exceptions handling. Do you know the word exceptions?
Yes.
Yeah, so that means if somebody does something wrong, so how to suppress that thing, how to handle this thing. We are not robots.
Got
We have to just talk. We have to solve the problem by doing dialogues, right? So this is basically these are the exceptions which deal with the negative and positive aspects of the instruction set. I would call this instruction set. This means that we are just focusing on algorithms. So now the key characteristics of algorithm, as we have already know that finite means an algorithm must always terminate after a finite number of steps. That means you have to write the complete set of instructions that will guide the user, that if they follow the same set of instructions, they can get the thing solving will be done easily.
Okay.
Right? For example, if I ask you to just write an algorithm to solve the or to expand the formula a plus b whole square, right?
Yes. Yeah.
Or a square plus b square whole square, then you must know that what steps are required to write. If you omit any of the steps, definitely you know that what the result will be.
Yeah.
Okay. So this is what that means in the finite number of steps. That means you have to keep on writing the steps until the solution comes. That
Yeah, I
means
got it.
your request is done. That means whatever you wanted, is it done or not? That means in the end of the article, as you would have seen to the Google search, was the article helpful or not? There are two buttons, yes and no.
Yeah.
Yeah. So this is what you have to just keep on focusing until the things are done completely. And if you think anything is ambiguous, that means you're talking about the negative and positive, that will impact the negative aspect. That means the user will understand negatively. So you will have to again explain that in a bracket.
Yeah, I got it.
Yeah. If this happens, then you have to deal this way. Got it?
Yeah.
Okay. Then definite. Each step of an algorithm must be precisely defined. Then input what I just explained, precisely defined means if you think that the impact would be negative, that the impact would be positive, so how to deal, you would be writing the instructions. Okay. The input, when you're taking the input, collecting some information or data from the user, the algorithm has 0 or more inputs. That means if you want to have something, for example, entry points where the user should input data and how many times the data should be input, how many prompts should be given. For example, entering your name, prompt number 1, entering your age, prompt number 2, entering your address, prompt number 3, entering your qualification, prompt number 4, entering your telephone number, point number 5, entering your email address, point number 6, and so on.
Yeah.
Got it? Then when
Yeah.
come to the output, this will be an algorithm produces at least one output. One output means, for example, if you have collected all the information before making it final, you must be displaying that instruction onto the screen so that the user can see that is that the output, is that the information you provided correct. If correct, click on yes.
Got it. Yeah.
Got it?
Yes.
Then how effective is this? The steps of an algorithm are basic enough to be carried out in principle by a person using a pencil and paper. That means how do you compose your form or the layout of the input form that should be effective. That means the user must be able to understand that what is being asked from them. Okay. It could be anything. For example, if the form is being generated or being designed for a patient, so the layout should be designed according to the good backgrounds, like the hospital background, and then you can see the pleasant layout and just asking something which is according to the user experience, what the user will be looking for. That means, for example, if you are asking something, that means how many visits you want to do in the hospital, okay, and which particular services you are required for, which doctor you want. So this would be differently. That means you are looking for. So these buttons or these types of things should give an impact to the user. That must be, they must be looking for. That means this should be there. If they want to find something, so these things should be located on the same screen. So the effectiveness would be carried out in principle. That means you have to keep the track of everything that should be, once you draw on the paper, that should be transformed into the digital output as well.
Yeah.
So you can see algorithms are not just limited to computer science. They are used in everyday tasks such as cooking recipes, solving puzzles, and even in decision-making processes. So you can see that how the algorithm is involved in our daily life, not only for one part solution. It is completely involved, but we do not call them. If you want to check your daily routine, this is also an algorithm. If you want your study routine, this is also an algorithm. If you want your food routine, this is also an algorithm, right?
Yeah.
Then moving on to the next part, that is algorithm. Part 3, how many types of algorithms? Basically, there are various types of algorithms are suited for different tasks and problems. Some of the common types include sorting algorithms. When you try to write sorting algorithms, they should be, that means you are arranging the things in alphabetical order, in ascending order, or sometimes in descending order, right? In reverse order or in forward order, whichever words you like, you can use them. Sorting algorithms arrange the elements of a list in a certain order, usually ascending or descending. Okay, now one thing they have used here, this is a list. Basically, list. What is this list? Do you have any concept about this list?
What list?
Yeah, what is list? Basically, it could be a list. For example, you are jotting down something on a paper. For example, buying a grocery for home. Buying a grocery for home, you will be making a list.
Yes.
The first concept derived this way, making a list of books.
Yeah, got it.
Right, making a list of notebooks. How many notebooks you want to buy, how many notebooks you have to manage, right? You have to make notes for, right? So basically a list, but this list does have a meaningful name in the computer science. That means list means an array like thing that can store in memory, right? They're using the sorting, right? So this is a sorting. That means you put something, like suppose, for example, I write Ibrahim equals to, this is the list, and how many subjects? Which subject you told me?
What for? Subjects for what?
Yeah, this is,
Yeah, just slightly.
and other one,
Chemistry
and third one,
and biology, English.
biology, and fourth one is the English. So this is the list. This is the computer-based list. Now you can see this Ibrahim will have these 4 subjects, right? When I write here, print So all the contents contained in this word Ibrahim will be displayed. If I want to make the heading over it, then I can just use heading, number of subjects. Here, see, you can see the print subjects selected, right? Can it be? Subject selected is a message within the print statement. And underneath, you can see you have printed the list of from Ibrahim that how many subjects you stored here. So digital society, chemistry, biology, and English, 4 subjects. They are all separated with the comma and they are enclosed with a single quote, right? So this is the concept of list. Got it?
Yeah, got it.
So this is stored in memory,
Yeah.
right? So then bubble sort. Bubble sort basically compares adjacent elements. They're talking all about the computers. They are not talking about that something that we write on paper. When this concept comes, that list and arrays, so this is basically they're talking about the computer's programming aspects. That means how the computer store programs, how the computer stores data into memory, right? Then we used to shift them into the filing object, file combination, file handling, something like that. Okay, so they're talking about the lists in this regard. List in a certain order. That means digital society, chemistry, biology, and when you want to sort, for example, D comes after C, right? So this should be sorted in a form of chemistry or B, biology, chemistry, English, and digital society. Digital society and English. The sequential order of this should be biology, then chemistry, then
the society,
and last one is
and
the
then
English.
English.
When you sort them, so C, B comes for B is lesser than C. So when you apply bubble sort basically the concept derives from this. The bubble sort means abruptly you sort. That means whatever the value you find least, then all the values as compared to all the values, if any value you find lesser than all the values, you will be sort them, you will be bring that to the first position.
Yeah.
Okay.
Mr. What are the like components that are in the algorithm? Like, what are the most like familiar ones?
Components,
Yeah.
the variables, instructions, constants, right?
These are all common, like in
These are the
each algorithm.
yeah, these are the components. These are the components here. See, these are the components over here.
Yeah. Okay. Got it. Yeah. Okay.
Okay, we did it just now. Second or first one, I think first one. This one is here. These are the components. See, components of an algorithm, variables, conditions, loops. These are all components. You have to keep on going with them. So this is the program. As you are storing something in memory, they're referencing the types of algorithms. Then in types of algorithms, they're giving you the overview of sorting algorithms, as how to sort. For example, you have lots of data. Your name starts with I. Lots of people are there, their name must be starting with I, right? So you are Ibrahim, maybe Inam, maybe Irtiza, something like that. Okay, so you can see that these words would be sorted accordingly. So now when bubble sort comes, compares adjacent element, that in the adjacent elements means whatever the least value they will find, they will pick that first and then they will start swapping by comparing the other values. If it is lesser than that, then it will make the order of those values. Then it will come to the final list of the sorted elements, right? So now compares adjacent elements and swap them. If they are in the wrong order, this process repeats until the list is sorted. Like this, I can give you example. Let's suppose 2, 1, 4, 3, and 6, 7, and 5. Let's suppose this is the list, right? You want to order it. How would you order this thing?
How or order what? Like
You want to sort
okay.
this. You want to apply bubble sort here.
So I'll put the smallest to highest.
Yeah, so that means the second part would be this, that you will be putting 1, then 2, then 4, then 3, then 6, then 7, then 5. This is the first pass. How did you do this? Yeah, this is the question. You compare these two values. See, you compare these two values. is 2 lesser than 1? No, 2 is greater than 1. So you swap this 1 to this position and you swap this 2 to this position, right? So this is why this happened. Okay, now next pass would be 2 and 4. So this is okay. So you will move on. That means 4, 3. Yes, there here you will be swiping. That means this time this would be 1, 2, 3, 4, and 6, 7, and 5. Right now you can see this is okay. This is okay. This is not okay. 6 is less than 7. This is also okay. 7. Yes, but here this is not. That means you will put 5 back. That means 1, 2, 3, 4, 6, 5, and 7. Then again you will compare this thing. This is okay. This is okay. This is not okay. So that means you will swap this thing, right? This is already okay, right? So now you will write 1, 2, 3, 4, 5, 6, and 7. This is sorted. So this becomes the sorting.
Yeah.
Got it? Now when you come
Yeah.
to this merge sort, then see the process repeats until the list is sorted. So now merge sort divides the list into 2 halves. That means you will make the 2 halves of this, or there are two lists, like I can show you 2, 4, 3, 5. This is list set 1, and another set is 8, 7, and 6, 9. These are 2 sets. These are 2 sets. You will first sort this one. This would be I'm just doing the last part, right? This would be sort. That means you will compare this. Sorry, this is 5, not just a minute. This is 5. Okay. Now this is from the beginning, it is sorted 2. I'm just giving you the output. This is 2. Then second is the 4 and 3. Yes, there you need to just swap these values. First you will swap these things, then 5. Right now, second pass will be in between these things, right? So this would be 2, 3, 4, and the last one is 5. Got it? So this is the sorted order.
Yeah.
Right? And then this would be the next one, 8, 7, 6. That means the 8, 7, 6, and 9. So now here you have to swap this. This would be 7, 8, 6, 9, right? 9. Okay, then you have to swap this one also, 8 and 6. 8, 6, this becomes 7, 6. Sorry, I've done something wrong. Just a minute. This would be 8 and 7. This means 7, 8, 6, and 9. Right now, next pass would be 7 is 8. They are already ordered. Then 8 and 6, just 6 is smaller. So that means this would be 7, 6, 8, and 9. Then you have another 6, 7. Sorry.
Yeah.
7. This becomes 7. Then 8, and then 9. So this will keep on doing until all the things are sorted. So these are 2 pairs of arrays, 2 pairs of lists. Now you are combining them. So when you combine them, that means when you join them, so this becomes what? 2, 3, 4, 5, 6, 7, 8, and 9. So this way, these 2 sets are merged and this becomes the final set of the list. So this way, this will arrange this thing. This will make this sorted list. Any question regarding this?
No, I don't have.
So, so we'll conclude the session today. So I will
Yeah.
try to send you some details about this thing so that you can get to know about all those things.
Yes.
So
Is it okay if you send me topic questions about this and exam style questions as well as the slides, if it's possible?
actually, I just need to get you remember. I send you the question paper with the answers. Have you studied that?
Yes, but do they include
It was paper
every?
one. Yeah, it was paper one. It was paper one. It was paper one. So I would be just sending you, uh, or you can just make me remind in between.
Do you have topic questions like for each unit or chapter?
I'm just sending you. You just make me remind so that I can send you on time.
Yeah, okay.
Okay. Okay. So we end the session. Okay. Take care.
Yeah. Thank you, sir.
Okay.